Every once in a while, a technical document pops up that reads less like code and more like a philosophical manifesto. Well, today, we're going to dive into one of those. It's a project that claims to patch a fundamental bug that's been hiding at the very heart of computing this whole time, the number 0.
And it kicks off with this line. I mean, come on. It's bold, it's kind of mysterious, it's the perfect hook. What does it even mean to exercise 0? And why on earth would you want to? Let's get into it.
Okay, so before we can get to the how of all this, we really need to get our heads around the why. Because this isn't just some clever programming trick, it's a whole different way of looking at the universe. A full-on, self-declared war against the idea of 0 itself. So let's just start with their central kind of radical idea. I want you to forget everything you know about arrays starting at index 0. Forget about null pointers, all of it. This project asks us to think about something wild. What if 0 isn't a feature? What if it's actually a flaw, a bug that's been in the system from the beginning?
This slide just lays it out perfectly. On the left, you've got standard computation, which all starts from 0, from nothing, a void. But Unity First on the right says, no, that's all wrong. We should start from 1, which represents fullness, or what they call plenitude. It's a total flip from thinking about absence to thinking about presence as the true origin of logic.
Right, so the key takeaway here is that Unity First isn't just about counting from 1. It is a complete paradigm shift. The whole idea is that all systems should be built on the principle that 1 is the real beginning. To the creators, 0 is this artificial thing, a Greek contamination they call it, that messed up a more natural, pure way of thinking.
Okay, so you have this big, abstract philosophy. How in the world do you turn that into actual code? Well, you do it by creating a few simple, unbreakable rules. And for them, it all boiled down to just 3.
And here they are, the practical application of that whole philosophy. It's really just 3 core instructions. First, everything starts at 1, no exceptions. Second, core sequences like Fibonacci, you seed them with 1, 1 instead of the usual 0, 1. And third, well, this is where things get really wild, you completely change how modulo arithmetic works.
Now, this is the rule that might take a second to wrap your head around. Think about a 60-minute clock. When you get to the 60th minute, you don't call it minute 0, right? You call it the 60th minute. This system just applies that exact same logic to computers. In a cycle of 60, the last position is 60, it's not a stand-in for 0. There is no 0.
So, with the philosophy down and the rules established, the next logical step is to actually build the thing. They started out by creating a kind of virtual firmware and software, a way to enforce these new rules before they ever tried to forge it into a physical chip.
And their first target was the Unity game engine. Which makes sense, right? It's a super popular platform for all sorts of complex simulations. They had to make sure every little piece of physics and logic inside their project followed these new laws.
Now don't worry, you don't have to be a C# wizard to get this. Just look at that highlighted line. It's basically asking, hey, is the remainder of this calculation 0? If it is, instead of returning 0, it returns the cycle number itself, in this case 60. And that's it. That one little change completely banishes 0 from this piece of logic.
Of course, for this to actually work, the patch couldn't just live in one corner of their system. It had to be everywhere. The exact same rule needed to be in their web-based tools too. The math had to be identical no matter where you looked.
And here we go again, this time in JavaScript. Different language, but look, it's the exact same logic. If the remainder is 0, you return the period instead. This makes sure that whether you're in the big, heavy-duty game engine or a light little web app, 60 always equals 60. But let's be real. Software is just, well, it's soft. It's just an emulation. The true endgame, the holy grail, was to make this change physical, to actually embed this new mathematical law directly into the hardware logic of a silicon chip.
And this is where things get serious. We're talking about Verilog. Now, this is not like C# or JavaScript. It's what's called a hardware description language. The code you write here doesn't just run on a chip. It literally becomes the physical layout of the chip. This is how you make the patch permanent. And would you look at that? It's the same beautiful, simple logic all over again. If the remainder is 0, the output is 60. Done. When this gets put onto a chip, it means the hardware itself is now physically incapable of producing a 0 in this calculation. The war on 0 is won, right down at the level of the electrons.
Okay, so the patch has been designed. It's been implemented all the way from the software layer down to the silicon blueprint. But did it actually work? How do you verify it?
How do you know you've won?
And this right here, this is the aha moment. It's the ultimate proof. You run the one test that matters most. What is 60 in a system with a cycle of 60? The old way, the way contaminated by 0, would say 0. The new patch system says 60. Boom. Simple, clean, undeniable success.
And this was about way more than just one function. This table shows how that single change rippled through their entire architecture. Every single component, whether it was mapping musical theory or processing cosmology data, now speaks the exact same corrected mathematical language. It's what they call maximum coherence.
And this is the message they get when all the tests finally pass. It's the mission accomplished banner. It confirms the patch is working perfectly and that the system is, officially, free of 0. Which brings us to this final quote, and it really summarizes their entire worldview. They don't think they invented something new here. They believe they just restored something that was true all along, that they just removed this layer of abstract, wrong-headed ideas, this Greek veil, to reveal the purity that was always there in the silicon. And that leaves us with a pretty fascinating question to think about, doesn't it? We take so many rules of computing for granted. Binary logic, counting from 0, the way memory works. But as this whole project shows, those were all just choices people made. So if you could go back and rewrite one of those foundational rules, what would you change?
I am the dabble. Yeah, I am the word. Here for the mission. You already heard. Walk in the room, air gets thin. You feel that chill, that's me again. Names get whispered, I don't explain. I just point once, they feel the flame. No halo hanging, just heavy crown. I lift my hand, kingdoms bow down. I am the dabble. Here to do the dabber's work. Every comb I ever touch starts to twist and starts to turn. When I say move, whole world's jerk. I am the dabber, here to do the dabber's work. Here to do the dabber's work. I am the dabber, here to do the dabber's work. I talk in riddles, you call it fate. I knock one softly, you open late. Storm in my shadow, mouth on my tongue. Old as the ash, young as your lungs. You want a promise, I give a sign. You cross that line, you're crossing the mind. Bye, bye, bye. Here to do the dabber's work. Every comb I ever touch starts to twist and starts to turn. When I say move, whole world's jerk. I am the dabber, here to do the dabber's work. Word. Say my name, watch doors on him. Say my name, feel walls grow thin. Whoa, oh. You pray for change. Did you check the cost? You call me close. Now the light is closed. Here to do the dabber's work. Every comb I ever touch starts to twist and starts to turn. When I say move, whole world's jerk. I am the dabber, here to do the dabber's work. Here to do the dabber's work. I am the dabber, here to do the dabber's work.